This webcast shows how early-level system analysis can be done by using a domain-specific modeling languages. What we have here is an example system, and we inspect early-level system analysis by using that. So basically we have an application model describing the behavior of the system, as well as the platform model in which we are running the system. So we have two kind of domain-specific models, and we do an allocation with these models and then generate the code for a simulation system, so we can try out different setups with this system and then basically see the results there and adjust the system accordingly. Let's see next the models. I'm using here MetaEdit Plus, and we have a domain-specific language for heating system, which is our domain here. So first of all, we have a platform model, and I'm using here domain-specific language for piping and instrumentation. And here in the toolbar you can see the different domain concepts like boilers, radiators, sensors, valves, thermostats, and so forth. So basically I'm modeling my system platform by using these domain concepts. I can also make connections here, and the language checks me rules, like for instance the pump P1 is not connected with an outgoing pump, so we can ask a pipe here and put the pipe connection with the sensor to the valve, and we can give them different domain-specific properties for these, like how long the pipe is, or what would be the cover, like we could change the thermally insulated the cover, and then we can see also in the notation that the pipe visualization is changing, so we can actually see which pipes are thermally insulated and which aren't. There's also behavior describe an application side, and here you can see a domain-specific language for the pump controlling, and here you can see the state machine for controlling pump. If the flame is detected, then pump put on. But let's do also other way around. So if flame is not detected, then we go back to the control pump and we give here condition if domain-specific concept not flame detected. In this situation we would like to take a pump off. So I add here a new role, and now the domain-specific language guides me to look what kind of things I can ask. So I can ask for the pump off. So we could put now pump off or on alternatively. In a similar manner we have also for boiler. We have the same for the heating system. We have other kind of machine state machines, and here are conditions. For example, if the boiler requires to be heated up or the radiator requires to be heated up, then we go to control burner mode and basically do actions there. Or if there's a negation that the heat is not required, then we do alternatively. Similarly, there are also models for the radiator controller, and also conditions here, like if the thermostat room temperature is smaller than set room temperature, then we should warm up the radiator. So here I'm using again domain-specific concepts. The language also has rules to put these together. So if we basically look the pump controller, and we would like to add here maybe a second pump, let's call it P2, and maybe it's a Venturi pump. And now if we have two different kind of models, we actually can check that these models are not correctly synchronized, they are not allocated correctly. So we can check different models and their consistency at the same time, because the languages are integrated. We also have here now possibility to run this, and for that purpose we are using here a platform, and we are using a platform from programming environment from PLC simulation from a Beckhoff TwinCut, and here you can see my platform, all different kind of services my heating system provides, like I can put burners on or off, or pumps on and off, and so forth. But this is just the platform, it doesn't do anything, it just provides me the services. What it should do is describe in these models that you saw earlier. The next thing, we would like to run this. So I would like to generate the code, and here is now my piece of code being generated in a PLC code, and here I can see still my base blocks that you saw earlier, but now there's also the behavior of this application. So for instance, what the heating system should look like, and individual implementation code like state machines for boilers or pumps, for instance. So here you can see the pump code. And now there are also no errors but few warnings, because we haven't done the allocation yet, and for that purpose we open the system manager, which provides us the simulation environment and provides the mappings from the generic code for the simulation system. So I'll import here the previously generated, or during this process already generated project file, where I can see now individual variables of that system. And basically what I need to do here is I need to map different kind of inputs and outputs that the system has in generated code to those inputs and outputs that I can then use in a simulation system where I'm running the heating example. So for instance here we could pick different kind of thermostats, TS4 for instance, and map the input value to the simulation value. And we don't, while you can see here the yellow is the input and the red one is the output, we only do it once for all these inputs, and the outputs are already done similarly. And then we can generate the mappings. So basically now we have done mapping from our generic code for the simulation. So the next thing we can do is we can rebuild this. Now no errors, no warnings, and we can try to run this. But let's put first the simulation on. I'll start the system. And now it should be okay, privileges, it should be running. And once it is running, now we can then also look how the system is working. So let's log into the system and let's start to run the individual steps. And now we should see that yes, the boiler is now 90 degrees, the room temperature is requested temperature 20 degrees. But if I start to use the hot water, cold water comes into the boiler, so the temperature in the boiler decreases, and when it reaches a certain level, this valve should go on and set the pump running, as you can see, and then also the burner is heating the system. But if I also raise the temperature for the room, now also the heating to the radiator goes on as well. And if I close the use of the heating, now the temperature in the boiler increases, and when it increases 90 degrees it should basically cut the heating and burner, and the burner cuts, so therefore also the boiler, also the pump goes off. So this is basically how it works, and here you can see the same system design, the platform model, together with also the behavior, like here temperature was smaller than the set temperature, and therefore we were requesting a warming up this way. And here we can try out different kind of systems and see basically what happens if the temperature, pressure and so forth increases somehow unexpectedly, or something surprising things will happen. So thank you for watching this video on early level system analysis by using domain specific languages in MetaEdit Plus.